We're continuing to look at applications using right triangle trigonometry. So the next example in front of us, we're trying to find the height of a statue on top of a building. So adorning the top of the building is a statue. From street level, 2 observations are taken 500 feet from the center of the building. The angle of elevation to the base of the statue is found to be 43.2 degrees. And the angle of elevation to the top of the statue is 46.1 degrees. What is the height of the statue? Okay, so we actually have here 2 right triangles. We have one that goes to the bottom of our statue, and it said that that one was 43.2 degrees at that angle. We know that this length in here is 500 feet. So that right there, if we wanted to figure out the height of that building, we could do that using this triangle. When we look at the other triangle, goes a little higher. This is still 500 feet. But the angle of elevation, and we haven't talked about elevation. Oh, maybe we need to. Angle of elevation. So there's a couple ways that we can denote how to find an angle when we're looking at word problems. Angle of elevation and angle of depression are ways that we can do this. When we're looking at the angle of elevation or an angle of depression, we're thinking of it as a horizontal line. And how are we rotating from that horizontal line? If it's elevation, we're rotating it up. If it's depression, we're rotating from that horizontal down. So this angle of elevation to the top of the statue was 46.1. So it's getting us that little extra piece in there. And so if we could take this whole side here, minus the height of the building, that would give us this little piece up here, which is, would give us how tall that statue was on top of the building. And so if we're looking at our angle, we're trying to figure out opposite sides. And so opposite of our angle, and then we also know the adjacent side. So again, we want to use tangent. So the statue's height, maybe let's call it S for statue. And this is going to equal the height of the building and the statue. And so we can find that, maybe let's call this X. So let's come back over to the statue in a minute. So let's look at what X is. So that is tangent of 46.1 degrees is equal to the opposite X all over the hypotenuse, not hypotenuse, adjacent, which is 500. So we get X here is equal to 500 times tangent of 46.1 degrees. So that statue, it's going to be the height of the building plus the statue, which we just saw was 500 tangent of 46.1 degrees. And then doing the other right here, this height, let's maybe call it Y. We can find Y by looking at the tangent of 43.2 degrees all over, actually, I did that wrong, opposite. So tangent of 43.2 degrees, this is equal to opposite, which is Y, all over the adjacent side, which is 500. So y is going to equal 500 tangent of 43.2 degrees. So we're going to subtract that height of the building off of the height of the building plus the statue. Okay, so this is at this point now a calculator exercise. And so let's do that. This will hold more room. So plugging it in, make sure that you're in degrees. And we have 500 tangent of 46.1 degrees minus 500 tangent of 43.2 degrees. If you look and you round this, this is approximately 50. Rounding it to the nearest whole number is 50. And we were in terms of feet. So 50 feet.